hypothesis, where you assume that the statement holds for an arbitrary natural number k, and then the inductive step to prove it for k plus 1. So this process demonstrates that if the statement is true for the base case, and whenever it's true for one number, it must be true for the next validity. It's true for all natural numbers. So, demonstrating or prove that 7 raised to n minus 6 raised to n is divisible by the 7 minus 6 equals 1 for all positive integers of n. So, our first step is the base case. So, let n is equal to 1. So, 7 raised to 1 minus 6 raised to 1 is equal to 1, and 7 minus 6 is equal to 1 is equal to 1. So 1 is equal to 1. So the base case is true. So since 1 is divisible by 1, it satisfies the condition. So our next step is inductive hypothesis. So assume that 7 raised to n minus 6 raised to n is divisible by 1 for some positive integer k. So let n is equal to k, and set it equals to 7 raised to k minus 6 raised to k. So our next step is inductive step. So we need to prove that it is also true for n is equal to k plus 1. So now let's consider 7 raised to k plus 1 minus 6 raised to k plus 1. So 7 raised to k plus 1 minus 6 raised to k plus 1 is equal to 7 multiplied by 7 raised to k minus 6 multiplied by 6 raised to k. So it equals to 7 multiplied by 7k raised to k minus 7 multiplied by 6 raised to k plus 7 multiplied by 6 raised to k minus 6 multiplied by 6 raised to k. So it equals to 7 multiplied by the quantity of 7 raised to k minus 6 raised to k plus 6 raised to k multiplied by the quantity of 7 minus 6. So for the assumption of 7k